So atoms are tiny and very light. They're made up of subatomic particles, which are the protons, neutrons, and electrons, which are smaller and lighter than the atom. So if we look at the mass, subatomic particles, so the relative mass of a proton and neutron is 1, and the relative mass of an electron is 0.0005. And that just gets rounded to 0, basically. So we can say that the relative charge of protons and neutrons is 1, so relative mass of protons and neutrons is 1, and the relative mass of electrons is 0. Now, in atoms, the relative mass is the number of protons plus the number of neutrons. And if you think of the size, atoms have an average radius of about 0.1 nanometers, or we can think of that as 1 times 10 to the minus 10 meters. It's very, very small. And if you think about that in scale, about 5 million hydrogen atoms could fit on a single pinhead. So they're really, really tiny. The nucleus of an atom is 10,000 times smaller than the atom. So if the atom was the size of Wembley Stadium, then the nucleus would be the size of a pea that you'd eat for your dinner. So can you remember the two analogies that help show how small atoms and subatomic particles are? So remember that if you think of a pinhead, about 5 million hydrogen atoms will fit on the top of that pinhead. And then if you think of the size of Wembley, so if you think of the size of a pea, size of Wembley is the size of the atom with all its electrons, and the P is the nucleus. Which subatomic particle does not have a relative mass of 1? So remember, protons and neutrons have a relative mass of 1, and the electrons have a relative mass of 0. The mass number of an atom, which we also call the relative mass, is the total number of protons and neutrons in a nucleus. So the atomic number of an atom is the number of protons in the atom. So atomic number is the number of protons, mass number, the number of protons and neutrons. This information can be found on each element in the periodic table. So if we take sodium, Na is the chemical symbol. You've got 23 above it and 11 below it. So the 23 is the mass number. So remember, that's the number of protons plus the number of neutrons. And the 11 is the atomic number at the bottom, and that's the number of protons. I'll look at another example. Carbon, chemical symbol is C. Above it, you'll have 12, which is the mass number. So there are 12 protons and neutrons in the nucleus. And the atomic number at the bottom is 6. So there are 6 protons in the nucleus. So the atomic number, just to recap, is the number of protons in an atom, or a particular element, and the mass number is the relative mass of a particular element. The element's atomic number tells you the number of protons in each atom, and an element's mass number tells you the combined number of protons and neutrons in each atom. And just to recap, the relative size of an atom versus the nucleus. Atoms are really, really small, but the nuclei are even smaller. So if the atom was the size of Wembley, then the nucleus would be the size of a pea. Just to recap, the mass number of an atom is also called the relative mass. It is the total number of protons and neutrons in a nucleus. The atomic number is the number of protons in an atom. This information can be found for each element on the periodic table. Now, the average size of an atom is 0.1 nanometers. And that's the end of the session today.